We're covering concrete compressive strength, F.C, and mixed design for the FE civil exam. The specified compressive strength of concrete, denoted F.C, is a fundamental property you'll see constantly. It represents the compressive strength measured from a standard 6 by 12-inch cylinder test after 28 days of curing. For the FE exam, you will typically see F.C values for normal weight concrete between 3,000 and 5,000 psi. Directly tied to F.C is the Modulus of Elasticity, EC. In the Civil Engineering section of the NCEES FE Reference Handbook, under the Design of Reinforced Concrete Components subsection, you'll find the ACI equation EC equals 57,000 times the square root of F.C. A common exam problem will provide F.C and ask for EC. You must be very careful with units. F.C must be in pounds per square inch, or psi, to get EC in psi. For example, if a problem states F.C is 4,000 psi, you calculate EC as 57,000 times the square root of 4,000, which is approximately 3.6 million psi, or 3,600 ksi. A classic exam trap is to provide F.C in ksi, such as 4 ksi. If you incorrectly plug the number 4 into the formula, your answer will be wrong. You must first convert it to 4,000 psi. Remember that concrete is strong in compression but very weak in tension, with a tensile strength roughly only 10% of its compressive strength. This is why we add steel reinforcement to handle the tensile forces. Now, achieving a desired F.C comes down to the mixed design, and the single most important factor is the water-to-cement ratio, which is the weight of water divided by the weight of cement. Lowering the water-cement ratio leads to higher strength and more durable concrete. The exam will test this conceptually, asking which mix is stronger based on different water-cement ratios. A common confusion point is the role of aggregates like sand and gravel. While they are crucial for volume, it's the paste, the combination of water and cement, that binds everything and determines the ultimate strength. Here is a memorable phrase to help you retain this key concept. Less water, more might. A lower water-cement ratio creates a mightier, stronger concrete. On the exam, you won't perform a full mix design from scratch. Instead, you'll be tested on these fundamental relationships: calculating EC from F.C, understanding the water-cement ratio's impact on strength, and knowing the roles of the basic components. Always double-check your units, as a simple PSI versus KSI mistake is a frequent and easily avoidable error. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.